Hey ladies and gentlemen, this is Miss Humbert here. Today we're going to be doing Unit 1 Notes 2. So we're going to be going over a lot of stuff that you learned in 8th grade, but today we're going to focus not just on solving equations, but actually writing equations to solve. So let's go ahead and let's take a look at Unit 1 Notes 1. Okay, so here we're going to fill out this chart. That way when you're writing word problems, you can use this chart as reference. So, for example, if you see something that says added to, increased by, more than, sum, addition to, you're going to be using addition. So we're going to be using that plus sign. So we could also see 5 increased by a number. That would mean 5 plus a number. If you see the words subtracted from, decreased by, less than, difference, taken away from, that's going to be a minus sign or subtraction. So 4 less than a number, 4 minus a number. Okay, also we see multiplied by, product, times, 1/3 of, 1/2 of, 3/4 of, twice. All of that means multiplication. Now in algebra we'll see multiplication either as a dot or as a star. We try and avoid using x for multiplication simply because we use x as a variable so often. So 5 times a number, for example, we would use that multiplication sign. So let's go ahead and let's take a look at a quotient. So a quotient means divided by. So we have two things for divided by. We first have just the normal division symbol that we're used to seeing, but we also use a fraction bar. When you have a fraction, like if you have the fraction 3/4, that can also mean 3 divided by 4. That fraction bar is also a division symbol. When you have something squared, we're going to take any number and raise it to the second power. Okay, so when you're raising it to the second power, squared is really taking the same number times itself, so you're just going to do that twice. Okay, so then let's take a look at cubed. So if I have a to the third power, well that's going to be the same as a times a times a 3 different times. Then if I have a to the nth power, I don't know how many times I'm multiplying a by itself. So I'm multiplying a by itself a bunch of different times, but we never really specify how many times until we decide what our n value is. So, is the same as or is equal to, and sometimes you'll just see is. The word is really important when you're talking about an equals sign. So here, see here, the length of a rectangle is twice the width. So is typically represents an equal sign. So those are key words you can be looking for when you're making a word problem. So let's just practice some of these, just setting them up so that we can kind of get used to it, and then we'll do some actual story problems. Okay, so the sum of a number and 16 is 32. So for each of these numbers, I'm just going to assign a letter. You could use the first name, the first letter of your first name. I just always use X, but that's just my preference. So the sum of a number, so we'll say X, and 16 is, remember that means equals, 32. Sum means add. The sum of a number and 11 is, so the sum of a number and 11 is 42. Okay, the product, so that's going to mean multiplying, of 16 and a number is 32. So we can do 16 times x is equal to 32. But something I want to point out is you don't often see 16 times x written out that way. A lot of times you'll just see it written this way. So when you have a letter and there's a number written out front, that means multiplication. Okay, so the product of 12 and a number, is 48. Again, that 12 times x could also be written as 12x. Okay? The quotient of a number, quotient, that means divide, of a number, and 16 is 32. Okay, the quotient of 12 and a number is 24. So 12 divided by, we can also use that division symbol, some number is 24. So notice whenever is second, that's what I'm putting as what's being divided by, whatever number is second. So when you're talking about division and subtraction, that order is really important. The fourth power of a number is 16. So we don't know what the number is, but we're going to raise it to the fourth power, and that's going to be equal to 16. Okay, the third power of a number is 27. So we're taking some number and then we're going to raise it to the third power, and that's going to be equal to 27. Try and challenge yourself a little bit. What times itself 3 times is going to be 27? See if you can figure it out. I'll maybe give you a special treat if you can come up and tell me. A difference between a number and 16 is 32. So the number is going to be first. Difference means subtract. And then I'm going to have the 16 as the part that's being subtracted by because it's second. And that's going to be equal to 32. 14 less than a number. So here we have to kind of look at the way it's phrased. 14 less than a number. So we're taking the number and we're getting rid of 14. So since it's phrased that way, we actually have to put the x first. So x minus 14 is equal to 3. So it's really important that you're paying attention to the way things are worded, not just what the specific word is. So let's go ahead and let's read through number 11. A rock climbing gym charges non-members $16 per day to use the gym and $8 per day for equipment rental. So I always like to note out numbers for myself. Okay, members pay a yearly fee of $450. So instead of paying $16 a day to get in, they're going to pay $450 for the entire year. And then $6 per day for equipment rental. So now what we need to do is we need to figure out at what point is a non-member going to be equal to a member. Okay, so let's go ahead and we're going to set that up. So let's figure out how much it would cost to be a non-member. So I'm going to let X represent the number of days that I go to the gym. So for every X time I go, I need to pay $16 to get in. For every X day I go, I also have to pay $8 for equipment rental. Now, if I am a non-member, or if I am a member, sorry, I'm going to start by paying that $450, so I don't have to pay each time just to get to the gym. I do, however, for each day I go in, have to pay that $6 equipment rental. So now we have this equation. We have 16 plus 8x is equal to 6x plus 450. So now what we need to do is we need to actually solve for x. So first thing I need to do is simplify this side. So what's 16x plus 8x? Well, that's going to be 24x. And that's going to be equal to 6x plus 450. So now what we need to do is we need to get our x's on the same side. So I'm going to start by subtracting 6x to both sides. So 24x minus 6x is going to give me 18x. And that's going to be equal to 450. Now that 18 is being multiplied by the x, so I'm going to go ahead and divide both sides by 18, and then I end up getting that x is equal to 25. Now remember we talked about that x represented how many days. When you're doing a word problem, you always need to put your answer in context of the problem that you're given. Let's go ahead and let's take a look at number 12. On July 20th, 1969, Neil Armstrong stepped foot on the surface of the moon. On the moon, his suit and life support weighed about 33 pounds. An item's weight on the moon is about 1/6 of its weight on Earth. What is the height of Neil Armstrong's suit and life support backpacks on Earth? Okay, so what I want to know is how much it weighs on Earth. So I'm going to let X represent our earthly weight. So X. And what I need to do is I need to do 1/6 of that, and that's going to equal how much it weighs on the moon, which was 33. Now I know a lot of students don't like dealing with fractions, right? So 1/6 is really the same as X divided by 6 is equal to 33. So now we need to go and solve this equation. So in order to do that, I need to get rid of and do the opposite. So since we're dividing by 6, I need to multiply by 6. So 6 times 33 is going to give me 198. And if we look at the original problem, our weight was measured in pounds. So that right there is our final answer for number 12. Let's go ahead and let's take a look at 13. It says, in a recent study of 13 to 15-year-old girls, 225, or about 9/20 of those surveyed, they talked on the telephone, watched television. How many girls were surveyed? So we're going to let X represent our total. So we know that 225 represents 9/20 of that total. So we need to take our total number of people surveyed. Whoa! Isn't that fun? Okay, we need to take our total of people surveyed, and we need to multiply it by 9/20. So I'm going to take 9/20 times x. Okay, so first thing I want to do is I want to take care of that divided by 20 because it just bothers me. So the first thing I'm going to do is I am going to multiply both sides by 20. So 225 times 20 is going to give me 4,500, and that's going to be equal to 9x. So then that 9 is being multiplied by the x, so I'm going to go ahead and divide both sides by 9. So I'm going to take that 4,500 and I'm going to divide it by 9, and then I get 500. Okay, so there were 500 total girls interviewed. For a second there, I thought we were on the previous problem. We were saying that it was how much Neil Armstrong weighed. I got confused, but we're talking about 500 girls. Okay, so let's take a look at number 14. The discharge of a river equals the product. So we got a couple of things coming in here. We have equals the product, and now product means multiply, the width, its average depth, and its speed. At one location in St. Louis, the Mississippi River is 533 meters wide, 0.6 meters per second, and the discharge is 3,198 cubic meters per second. How deep is the Mississippi River at this location? So let me just take this first sentence and I'm going to put it into equation. So the discharge of the river equals, so I'm going to let D represent the discharge. The product of the width, its average depth, which I'm just going to say A, and its speed, which I will call S, or pace, apparently. S. Okay, so D was, apparently. Okay, so we know the depth. We know the discharge, sorry. The discharge was 3,198 cubic meters. We know the width was 533 meters, and we know the speed. So what we don't know is A. The speed was 0.6. So I need to solve this equation for A. So the first thing I'm going to do is multiply 533 and 6. So 533 times 0.6, sorry, is 319.8 A, and that's going to be equal to 3,198. So now I'm going to go ahead and divide both sides by 319.8. And when I do that, I end up getting 10. So A is equal to 10, and I need to look at what the depth was measured in. Well, since the width was measured in meters, we also need the depth to be measured in meters. So 10 meters is your final answer. So that concludes your note video for today. Thank you for listening. Let me know if you have any questions.